All right. I guess this is everybody. I think so. Well, hey everyone. I'm Lucas, and I guess I'll be doing a chat about large-scale system architecture in Touch, and I'll be doing it through the context of GeoPix, which is basically the best way to describe it is a pixel mapping software that's more of like a sandbox for lighting design. It's 3D sandbox, and so. I guess with that said, just dive into it. Hopefully, if you guys have any questions, I love the Q&A thing a lot more than just like the steady like onslaught of words and things. So yeah, just interrupt me if you have a question or a thought. I just enjoy that a lot. So, and then in the middle, we'll have like a Q&A and a break. And then at the end, we'll probably have some time left over. So yeah, all right, let's dive into it. So just a bit about my experience. I kind of come from a 3D background, doing a lot of work in like Maya and Blender more recently. And so I guess I kind of got into the node-based stuff, starting out there with like the Maya's Hypershade and things like that. And one thing led to the other, and I found Touch through Amon Tobin, a set of his I saw live. Had no idea what I walked into, and then I just immediately looked up the software the next day, and it's like, well, this is what I'm going to do for quite a while, it looks like. And so from there, I just started getting into LED projects and doing more pixel mapping, starting with like a breadboard and just a couple LEDs, turned into an 8x8, and then before you know it, I'm trying to come up with ways to do this software stuff. And in the last 3 years or so, I kind of started with GeoPix 0.9. I was learning a lot about Touch. I didn't really know a whole lot about software design because, granted, I came from like a 3D background, so I was clicking buttons, not making buttons, I guess you could say. So at one point, I kind of put that on pause, and I started working with ImagineX, and I did some development there for Crescent Sun, which is their media server software, and then sometime after that, I kind of came back to GeoPix, and I did a reboot, and I called that 1.0, which is a little misleading. It really should be like 2.0 because it's a totally different software, but that's where we're at today. So with that, I guess I wanted to kind of take a quick poll and just see kind of what everyone's like into and kind of what their focus is in Touch, just to give me some, I guess, better ideas of kind of what you guys are hoping to get out of this, and hopefully I can steer this in a better direction. You guys want to just like kind of just do a quick rundown, just like what's your main focus in Touch, I guess, and what do you like doing? Generative systems, cool. Sweet. Cool, cool. Nice. How about you? Sweet. Okay. Cool. 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 Awesome. Cool. Cool. Oh wow. Small world. Yeah. Cool. Awesome. Awesome. Okay. Cool. 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 Sweet. Sweet. Awesome. Cool. Wow. Awesome. Holy cow. Cool. Sweet. Awesome. Cool. Cool. Awesome. Cool. Awesome, sweet. So a lot of media server stuff and LED stuff, and well, cool. Hopefully this is going to be cool, and I'll kind of steer this in a direction that will be as interesting as possible. So the outline for today, Kind of want to do like a high-level overview of GeoPix and kind of how things I guess are organized in a few areas, and then after that, there's 3 main tabs of the software, which are kind of down here, and I just want to walk through different workflows I've applied to each of those. It kind of has been useful to think of them in different ways, and then break Q&A, kind of however much time we want to spend there, and then we'll dive back into like the more of the nuts and bolts stuff, which will have most of the examples and most of the stuff you can look at in that toe will be in those last 5, 6, and 7. So you can just kind of chill and kick back for the first half, and we'll hopefully just be interesting to like digest. And then so at the end, final touches. I won't spend much time on this. I think Matthew did probably a very good workshop on Python libraries, but I have some external stuff and like bundling that's worth mentioning, installers, stuff like that. And then if all that gets done super early, I've got some extra stuff at the end that I can just show you some like things that I got on the horizon that might also be interesting, I guess, from like a development standpoint, some challenges with it. So yeah, that's the outline. So diving right in, the first thing I'll do is I'll just go ahead and show you guys, I guess, just a very brief demo so you can kind of see, have some context for some of the workflows and stuff going on. And if you've seen GeoPix before, this will probably all seem like a repeat, but in case there's anyone new out there, for the people watching, I'll just go ahead and do this. So you have a 3D viewport, and it's modeled heavily after software like Maya and Blender. It's kind of where I come from, so I pulled a lot of inspiration from that. So you basically start a project by making a fixture and doing various types of additions to this through hulls and picks. But actually, before I do that, I might want to bring in some geometry to mock up a scene, for example. So I've got a very small demo scene I've set up in Blender. So I've got an archway here. This might be like something at a festival or a trade show that you'd walk through. I'll import a few more pieces of geometry. It's a ground plane. And I just have a mesh of some people here for scale. And so from here, I would take this fixture I made, and I would start adding hulls. Hulls are basically a framework that you would add to a fixture that allows you to generate pixels kind of across them. So it's basically giving you, it's allowing you to create a few points and then extrapolating that or interpolating that later with various tools. So I can kind of just start clicking here with these snap points. I can start adding these hulls to various points. And it looks like I got these a little bit off, so I'll fix that. So with that done, I can go over here to select all, grab those hulls, and do a generator, which will basically attach a new object to the fixture, which generates pixels kind of dynamically. So you can adjust settings, and you can have this kind of generation update kind of in real time. So I'll do that real quick. I'll just set 100 here for just a rough pixel count. And just to kind of show you, one of the cool things about hulls is you can grab these and you can move them, and the whole pixel strip will kind of flow with it. This does kind of eat up performance if you have a very heavy fixture, but that's something I'll get into later with performance and optimization. So at this point, I'll just duplicate this a few more times, and I'll go ahead and make some new hulls for the next one. And so this workflow would continue until you have, essentially your structure mapped. It could be a wide variety of things, but I won't spend a whole lot of time just mapping this out. I'm going to open a file I already have done with these strips already on here. Let's see if this opens. Cool, so turn off. Actually, that's fine. Okay, so this is a few steps forwards from where I was a second ago. Basically, what I did was I set up a couple moving headlight fixtures down here, which are definitely a work in progress in GeoPix, and I'll explain why later. But the primary thing is the LED strip workflow. So if I go ahead and turn on these projectors, you'll be able to see kind of how things are put together content-wise. I'll go ahead and turn off all but one here. So the cool thing about GeoPix that really made it A, hard to develop, but B, I think really unique is that you can take content that's 2D and you can transform it and kind of project it onto your scene in 3D using these projector objects. It's not a new concept or anything like that, but in terms of LEDs, I just think it's been relatively unexplored. So using some tools like the style of the projection, you can set this to maybe a orthographic projection. This doesn't really look all that noticeable on a piece like this, but if you had kind of a big array of pixels, you'd probably see like that perspective warp kind of from the center point. And so, you know, in the future, things like spherical projection and cylindrical projection would make this even more kind of interesting, more wacky, maybe actually useful if you're doing a dome type of setup. Anyways, that is the kind of general system here. In terms of workflow, you have your attribute editor here on the right, and you have kind of a toolbar on the left, outliner. We got an I/O tab, which is kind of where you source your textures. And I know it's silly, but it's basically like TouchDesigner, but not quite as awesome. It's a little bit less featureful, but it does the trick, and it allows people to kind of build things and do things in a modular node-based way. I feel like I don't have to sell that workflow to anyone here. So in addition to the I/O tab, you have the Perform tab, which is when you start, it's blank. So you can basically make your interface, and you can trigger things and however you want. So if you have a pretty complex system, you might want to have more things on here that you can control. But if you just have a simple thing you're giving to a client, you can say, all right, here's a button to turn it on, here's a button to choose your preset, and then there you go. It's pretty bulletproof in that sense. So a couple other things you can do with fixtures before I kind of wrap up this part of the demo is masking. So masking allows you to, on a per pixel basis, go in here and select individual things, and you can create a mask. I'll call this Summit, and I'll just create this. And the cool thing about masks is that they play nicely with projectors. So if I reset this, and I'll just do a static color so you can kind of see what's going on here. If I take this projector and I assign that mask, it will only apply that content to just these pixels. So very useful for kind of creating special looks that only apply to certain things. The last thing is, you know, to make this compatible or at least more usable with moving head lights, I feel like there needs to be, or I felt like there needs to be a way to kind of interact with lights in a channel-based way. So you're moving channels on a lighting console. That is definitely a paradigm you need, even though the video stuff is really cool. So to kind of accomplish some of those things, we have the PixFrame editor, which if I grab these movers, it's very straightforward. It's essentially, if I can find it, where did they go? Weird. Could be a bug. First time that ever happened. All right. So there would be essentially sliders here that you can move up and down to control these. Here I can just go ahead and start this over and show you that one last thing. All right, so to do a quick fixture, so here's that fixture. We can open the PixFrame editor, grab this. Yeah, there's definitely some issues here. All right, well, I'll leave that for another time. But essentially, you'd be able to move sliders and, oh, there we go. Didn't have that selected. All right. So yeah, you can adjust the pan and tilt. Maybe I'll make this red so you can see it. And there's pans, so you can rotate things around. So you can basically set up a static look, and then in addition to the static look, you can use animations in conjunction with that. So you can have a combination of static looks and animation, and you can mix and match them however you want. And so that's, I think that's the primary things to kind of point out in the demo, because I think most of the things we'll talk about will kind of touch on those things. As far as the dynamic light simulation you saw earlier with kind of the light casting from those pixels onto surrounding geometry, that's I think that's something that'll be interesting to a lot of people. It's very it's definitely a hack, because there's no, at least currently, there's not really a way to emit light from 10 or 20,000 points in real time. There actually is some ways to do that, but I'm going to get into that later. if we have time. It's a really interesting technology I haven't really started to look at too much, but anyways, that's going to play into kind of some of the workflows and techniques that are used to optimize stuff like that. All right, so with that said, all right, so anatomy of GeoPix. So when you make objects in GeoPix, and I'm going to go ahead and get into the network now. It's quite familiar in terms of like how things are stored. We have a geocomp here, which is scene geometry, and you have essentially every object you create shows up as an actual object. So one of the things I wanted to do with GeoPix was make it object-oriented, because a lot of 3D software is, and also Touch is kind of object-oriented. So it made for a good platform to use some of the workflows they've already built and leverage some of the things they've already designed, like custom parameters and operators. So I didn't want to reinvent the wheel, because I have a habit of doing that sometimes. And so what I've done here is I take this comp and basically it's got a set of custom parameters, and if I adjust these, you'll see that we're doing the exact same thing that this will do here. We're just moving those sliders. And this also introduces kind of a interesting, well, I'll come back to this later, but there's kind of an issue with feedback loops that we'll talk about here in a bit, but that's a little bit, I'm sure it's a situation you've all run into before, where you have a UI and you have a parameter and you move the UI and they kind of start a cyclical feedback loop, and it's just like, how did I get here? And so that's the thing I've struggled with a lot, and until like maybe about a year ago, I started to realize kind of where it is that I was going wrong in more of an abstract kind of generalized way. So I think that's a very useful thing to kind of think about, and I'll get into that here momentarily. I was going to bring that up. Yeah, binding is a game changer for sure. Yeah. Cool. So the way I look at viewers in GeoPix, and a viewer is basically any pane or editor that edits some kind of data somewhere. So a UI, I would consider a viewer, just to use consistent terminology, and so is this kind of 3D viewer. And I would also say that the outliner is also a viewer. And this might be a concept, I guess, that's maybe more popular with software development. But again, coming from a 3D background, I didn't think about these things, and so kind of realizing this was a really big plus for me. And the realization was that when you have UI, I often thought of that UI as the data itself was stored in that UI, which it is. A lot of times you move a slider, and your slider has its own position stored in it, which, like you said, binding actually solves this problem in a different way. And I think that's something, I haven't even started to explore that yet, and I want to, but the thing that I started doing was kind of decoupling the data, or from the editing of the parameter from the drawing of the graphics. So to give you an example that I think is pretty straightforward is maybe this UI. Yeah, so this UI, when you move this slider, I'll go into the actual tech that I made this UI component with. It's actually not comps per row. It's a little bit different, but the concept is like you move your mouse and you click and drag on a certain area, and you're editing that custom parameter that is the main storage of data. But what happens after that is that custom parameter is now driving the graphics behind that slider. And I know that seems kind of like a redundant, like, well, yeah, of course that's how it works. But when you think of it that way, it's like the reason it's a feedback loop is you, right? You're moving your mouse and you're moving that item on the screen. Because you have that feedback from the graphic that's telling you where that slider is. So if you take yourself out of the equation, you've broken the feedback loop, and therefore you don't have a feedback loop to worry about in Touch. I know that's kind of a weird way to look at it, but this is kind of how I've been thinking about it more recently. So if you think about it like that, you're actually editing the data that only exists in one place, and then that data may be updating one thing, it might be updating 3 things, it might be updating 5 things, right? But the important thing is that data exists in just one place, and that keeps it from getting kind of discombobulated, where you have data in one place and you got to sync it to something else somewhere else. And so that's kind of the mindset I have these days when I think about this. And binding solves this in a very elegant way. You don't have to change your workflow, and so that's really awesome. And that's something that I think is probably the first line of order to check out. But for me, there's been some situations where I'm like, okay, this probably could use a more custom approach. And to give you an example of why that might be helpful here is the outliner. So The outliner is essentially a list view of your scene. So if I have two objects here, you can see that if I name this object, let me go in here and change this manually through the custom parameters. So if I have a name called primitive1 and I call this test, this actually doesn't update here, but that's because nobody would ever change it from here. But essentially, oh, I think I had the wrong one selected. Let's see here. Cool, yeah, so if I change this to something different, you'll see that the data here is updated and the data also is updated here, and that's because it's a one-way stream, right? The custom parameter name is being applied to some rendering graphic somewhere that's basically displaying that for you. So if you think of it in terms of like custom parameter to UI, it's a one-way street. There's no information coming back that's in that same level, but the information that is coming back is of course what you do with your mouse and your keyboard and your interactions. So if I parent this to this object, I'm not actually parenting this comp to that comp. What I'm actually doing is parenting this geocomp to this geocomp. And what that does is it tells this UI how to render itself. So I'm kind of restating the same thing over and over here, but again, it's just this concept of decoupling like the data in, data out to two separate operations. And even though it looks like you're doing the same thing, you're often not. And so that's helped me tremendously in terms of like kind of avoiding that problem of like cyclical loops and stuff like that with UI. Probably, yeah, yeah. Okay. See, and that's the kind of thing where like coming from the background I came from, I come up with my own words for it. But yeah, this is not the first person to come up with this for sure. But yeah, so that's kind of that section. Let's see here, data infrastructure. Cool. So kind of with that primary thing out of the way, another way I look at UI and at least GeoPix, for the most part, this kind of breaks down in some instances as primary and secondary. You know, in GeoPix here, I would consider this scene geometry comp as like a very central part of the software. So I would consider that primary data. And same with the I/O tab. There's a graph here, and so if I actually go to the I/O area, there's a very similar looking section called I/O scene, where you can kind of see all of the objects here, and they have custom parameters. Whoops. So I consider that primary data, and I guess it's up to you kind of how you distinguish those things from secondary data. But the reason I bring that up is because primary data is probably more likely to be edited from more than one source, and it's also probably likely to send its information to more than one renderable area. And so, give you another example of that, maybe actually a better example than this one is to let me just drop a fixture. All right, let's say we have a grid here, and we want to set the universe and channel offset. We can go down here and we can set the raw data just by moving the sliders and setting the absolute universe, however you want to do it. But in addition to that, you could also set this visually with kind of more of a block-based approach here. So we have this editor here that lets you kind of drag this block around, and if I scroll down here, you'll see that we're really just updating the same data, but we're updating it a different way with a different kind of view or model, if you will. And at the end of the day, it's just editing the same single source of data. So that's kind of a really practical way that comes out and gets used. So other examples, I guess, of primary UI that breaks a little bit from that is the left bar here, the tools. And since this UI is based on custom parameters, the way I kind of made this all mesh together and work the same way is I create a bunch of base comps here. And these base comps have they have their own custom parameters as well. And so depending on what mode you're in or what context, so if you're in object mode, you're going to have a certain set of tools available to you. And if you go into Pix mode, you're going to want a different set of tools available to the user. And this is actually a little bit of an older setup. I might have done this differently nowadays, maybe enable and disable custom parameters dynamically so that you don't have to have copies of the same objects or the same functions. So for example, select all is a is available in the Pix and the whole category, right? So there's no need to have that twice if you're doing more or less the same thing. But this was an easy way to separate it, and for the most part, I haven't had to do too much revision to this. So what I'm essentially doing is I'm feeding this UI component a different base comp that has a different set of parameters. And then from there, it pretty much automatically populates this here in the UI. So, all right, Outliner. Outliner is a good example. So this UI system I have now, I built relatively recently using the web render top, and I'll show you guys how that works. It's actually in the example file if you ought to use and keep and do whatever you want with. I'm going to release it probably in a couple weeks, but just wanted to get it out to you guys here. So this has several advantages, and again, I'll get into those in a bit. The main advantage is that the UI is being rendered as one big top. It's not actually too many separate components, and this makes it easy to work with in real time. The one area that kind of has that flipped around is the outliner, and this is how I used to build all of my UI. I think this is pretty standard, is just having kind of a replicated UI where you have a comp with an internal network with lots of nodes. And I will definitely come back to this, but I wanted to show you this because this is kind of like, this has inherent challenges with it. Sometimes it's not an issue. It really depends on what you're doing, how big of a software, and is that UI being dynamically regenerated. But that's kind of a central primary UI as well. Let's see here. The attribute editor, same way. It's, again, pretty simple thing. It's simple in concept, difficult to build efficiently, but this system is basically wrapping around custom parameters. So another example of a secondary UI would just be something like an OSC manager where it's editing data that's in a different location. This isn't actually object data. It's kind of its own repository of information, and this particular thing isn't modified from anywhere else. But again, to make it consistent in the software, I have a set of custom parameters on this thing called OSC manager, which actually I'll show you because I think this is useful. So the way I treat components here is, where are you? So OSC manager, it's got a bunch of custom parameters here for setting up that OSC in chop. I could have set this directly to the chop here, but instead I kind of go through that layer of custom parameters to kind of keep things consistent and kind of add like a buffer layer between it. So if I need to add additional logic between the parameter and the actual value being set, it's just good to have that buffer. It's just like having an extra layer there to kind of modify and change. So that's kind of its own data. Nothing else edits this, only this window here. But despite that, keeping things consistent really helps to like keep the workflow the same. Additionally, I use extensions pretty heavily, and I'll come back to this as well. Just mentioning it because extensions kind of help you treat that module as like a thing that you can command to do something. Hey, turn off. Hey, turn on. Hey, set your IP address to this. And it makes it very generalized in a lot of useful ways. So. Any questions? I want to make sure I stop and check. No? Cool. All right, so moving on. Cool, so one of the other things that was really important to the workflow is because in a software like this, you're constantly creating and deleting nodes or components, I guess you could say. It's really, you can't rely on things just being wired up a certain way and working. You can use replicators, and that gets you pretty far, but at some point, you're going to need more manual control over creating and deleting and parenting and unparenting objects, and sometimes you want to set parameters based on other objects, and there's a lot of things you might want to do. So I've had to integrate Python as a pretty huge component of this entire system, and it's been useful because once I have a Python function set up, I can basically call that function from anywhere. It's pretty straightforward concept, but it's really helped a lot because once I've developed this this feature, this tool, once I add something else somewhere else, I can execute or call that quite easily. OP fine. All right. So, and one last thing about the scene geometry here. The issue. And I'll get into this kind of topic as well later, but I kind of also look at programming now through kind of a lens of like a centralized object structure or data structure versus a decentralized. And the reason why that's useful is because there's inherent advantages and disadvantages to both structures, depending on what you're doing. But of course, with this geo holder, this is decentralized, meaning every object is its own object, and you can interact with that. And for the most part, it's not going to affect any other objects in the scene. But the problem with that is you need to pull all that information together, at least in some way, so that you can interact with that downstream. You have a collection of all of your fixtures in your scene. You need to be able to know what the state of every fixture's visibility is, or maybe you're dealing with like pixel counts and you want to like total that up. There's a lot of reasons why you'd want that. So to do that, I actually use an OP find, which when I first started using this node, I overused it because I thought, wow, this is the coolest thing. I can do everything with this. I can query every single parameter I want in addition to the objects. But the problem with that is every time a parameter changes, that DAT cooks, and everything downstream has to cook too. So you run into optimization issues with that. So the way I've set this up, this OP find, it gets the least amount of information possible to build a scene list. So it's essentially the name of the object, the fixture path, and a parameter called object type, which will come up later. That's basically how I tell the render picker and other parts of the software what I'm clicking on in terms of object type. And having it set up this way is great because it almost never cooks. And because it almost never cooks, downstream things can work out a lot more efficiently. And again, I'll get into that here in a moment. This is actually supposed to be high-level overview. I'm kind of already diving in, but cool. So that's that. The viewport is quite an interesting. It's a little bit different. It's also a little bit of an older part of this network, so it's not quite as organized and clean, but it does work pretty well. The main things to note here, it's a little bit like the ArcBall camera. You can move and navigate around. Render picker is a very important part of this, obviously. You have this, which is going to give you information about what your mouse is over. So let me just go ahead and make a few different object types. Get a primitive, a group, I guess. Okay, so one of the custom parameters that exists on each object is this thing called obj type, object type. So every single object has a different type number, and so this allows the because this is being fed into the the point attribute stuff in the SOP world before it's rendered. So whenever I mouse over something, you can see over here where it says ID X, it tells you that object number. So when I mouse over this, it says object ID X. So when I click on this, the render picker knows what we're about to click on, and it also gives us the ability to choose the context for the next action based entirely on what your mouse is over, which is great because the alternative is to have a million toggles and switches that you have to set manually that say, hey, this is what I'm doing next. And I started out kind of programming things like that. It's very verbose and it takes a lot of time and it's confusing. And most softwares these days, you just take that for granted a little bit, maybe, at least I did, where you click on something and it just knows what you're clicking on, and 100 assumptions go into that sometimes, maybe more. So this is really helpful to building out a render pick kind of execution here, or function. So I won't go into this too much. It's just a lot of Python, but essentially we have a lot of if statements that determine what mode we're in. Is shift being held down? Is control being held down? Are we dealing with this particular object type, or are we dealing with this particular object type? And so a lot of things happen directly through the render pick that makes it quite efficient and nice because it's immediately picking up that information. And with those Python functions, I can say, hey, go select this one object that your mouse is over. And it selects it, it adds it to the list. It doesn't matter where it is in the network because OP shortcuts and things like that make it really easy to kind of access that from everywhere. Let's see here. So that's kind of how the render picking works. The one other thing kind of to mention here is probably the way I have renderables organized. So if I show you the render, this is kind of the main render top. And if you look in here, it's basically getting a list of geocomps. And so I have geocomps split up by type. So there's type 1, type 2, all the way to type 50, which is, I think, snap coordinates. And so this is a very simple just OP find, just pulling a list of object comps, and it's getting it by name. And so where it's getting this from is over here, which I'll go back into this part of the network later, but the main thing to note here is that main OP find that got the list of scene objects. That's basically all objects, irrespective of type. So what happens in this section is that's split up. So all my geometry objects go up here to type 8, and then all my projector objects go to type 9. And then inside of each of these categories, I have kind of a replicated network that handles the creation of each actual renderable geocomp, and it pulls its transforms from the source, so it doesn't actually have a duplicate set of transforms. And the reason why I didn't keep this in the main viewport or the main geocomp, let me go ahead. So yeah, back here in the scene geometry, something I did in the beginning was I actually had all of my renderables inside each of these things. It was very self-contained. I could just copy that and paste it, and the whole thing just worked at first. But the thing that started happening was certain things were not. It was harder to pull data together sometimes, and there's certain things that were just going to be faster batched. So, for example, rendering the pics on screen or the pixels. Right now with one fixture, it wouldn't really matter if I was rendering that from the original geocomp or if I was rendering that from kind of a consolidated like collection of all the geocomps. But when you have like 20 or 50 fixtures, every little inefficiency between all the geocomps really starts to add up. And so having all of this stuff as simple as possible in the geoholder, and this stuff is dead simple. There's not even anything to render in here. It's just a few scripts inside. And that's pretty much it. Where the actual heavy lifting happens is in this container here. And just kind of show you the fixtures. A lot of stuff happens here, probably more than any other object type. But what ends up happening, if I duplicate this fixture, so basically these get replicated. A lot of work happens in each of those, which I'll come back to. But these things get joined and merged into one big instance, basically render of those pixels, and that's just more efficient than doing things separately, on a case-by-case basis. So that's the reason I have this split off, is so that I can actually replicate and manage consolidating or not in a more type-based format. So type 2, type 3, and each of those gets rendered as a geocomp. So it's a very simple thing to kind of throw at the renderer when you're ready for that. So, all right, so I guess that's it for that slide. Yeah, so the outliner I already talked about, but I'll just touch on this extra point briefly. So this is going to be replaced by a newer version of the outliner because it's not very efficient when you have 20, 50, or 100 objects in the scene. In fact, it gets really heavy because you're replicating these containers, and each of these containers, I'll just go and show you. If I drop an OP find, and I just go ahead and do a quick node count, so 112 nodes per item. And if I copy and paste one of these, the cook time to kind of initialize and get everything rendered is about 3 milliseconds, which isn't bad by itself. But when you're duplicating, a dozen or 200 or whatever, you're really going to feel that in the UI. And since the outliner is something that updates pretty frequently, although statically, it definitely is a thing to update and kind of optimize. And so the reason I mentioned that, well, yeah, that's pretty much all there is to say. Actually, it's just a very you don't know how your users are going to use the software. If you're building something for release and you're going to give it or sell it or whatever, it's going to be out there in the world. People are going to be interacting with it. You might have a certain kind of test case, but other people might be doing crazy things with it, and you have no idea. So making it as scalable as possible is well, it's really the point of this workshop, but it's also the thing that each of these components you kind of have to go in and really focus on that and kind of find ways to scale it. So yeah. All right. Looks like I've already talked about some of these things. The only thing I haven't mentioned in here, so in addition to these outliner, we have some other bins here. And they're all kind of working the same way. They're especially common here. You have each object type you can create in the I/O tab, video clips, MIDI, generators, stuff like that. Okay, so that's kind of the overview, and now I guess I'd like to dive into some of the more kind of workflow stuff. And to start, there's this concept that again, it's pretty straightforward once you start thinking about it. It's not a kind of a radically new concept or anything, but I didn't separate the work I was doing into these kind of categories, and thinking about it like this definitely has helped me. So when I think about like chops and DATs and anything that's flowing down like a network stream, I tend to think of them in three categories. Are they static, are they burst, or real time? And burst is kind of the most gray area because you might have something that updates a couple frames. You might be updating something for a couple minutes, but then it stops before you deploy or do your art installation. I think about these things kind of in these three modes because there's different parts in your network chain that you definitely want to apply or merge. So I used to merge all of my chops and all of my DATs into one stream because it looked nice and clean in the network. But the problem with that is, at least in DATs, and I think, well, yeah, both chops and DATs, if one value changes, everything cooks, and everything downstream has to basically recalculate, or at least check to see if it should recalculate, and that's a nightmare and kind of a headache too if you're like doing all these custom scripts to make sure, do I update the data, do I not? Something I used to do with self-optimizing networks was I would create like a chop execute that if, or a data execute, where if the data changed, it would copy that data to a table right next to it. And so that was a way of like basically making a selective null dat. But the problem with that is it broke the pull-based cooking. So if you had some edge case where something caused that node to update, but it didn't properly cook or it didn't copy it over, then you had like a discontinuity in your data, and troubleshooting that stuff can take more time than it should. So finding ways to kind of break things up into static bursts in real time really helps a lot when you're using the pull-based system because things can kind of get lumped in together and they can just be really, really expensive. Okay, so let's see. Yeah, so some examples of static things. So the way things kind of come into being in GeoPix, things kind of begin in the scene geometry, but they actually don't start there. They start in the templates comp, which is where I create the templates for all these objects. And inside the templates, we have each of the object types that you might create. So we have object, geometry, we have the fixture template, device, etc., etc. And inside of each of these templates, which are clones of themselves, we actually have these modules I showed you a second ago, which are actually clones of a further upstream kind of template. So if I go over here to the master template, there's a whole bunch of stuff here, and basically this is where all of the source stuff lives, basically. So we have data block. This is something that exists in every object. So for example, the primitive object has it, and its purpose is the same as all the others. So go and make an object, and I'll show you how this works. Primitive. Cool. So we have a primitive here, and if I go into the data block container, this is essentially what it's doing is it's taking the transforms of this object and it's converting it to the, well, it's taking the world space transforms and it's also taking the local space because both are used further downstream, and it's merging it together into this X form, and this is actually being selected elsewhere. And the reason why I'm kind of doing things like this where it's separated is because you might be moving one object and you have 15 other objects, you don't want those to cook. So this is a way of like controlling the cook streams of each object individually. So to kind of show you, make sure I'm not missing anything here. One last thing. No, I think I already showed you that. All right, cool. So the data block, you have two objects. Let's go over here to scene elements, which is where all the heavy lifting is done. We have so we have this dat table. We've got both primitive objects that we just looked at, and so this is where the actual renderables are generated. And now, if I grab this object and move it around, you'll see that we're only cooking the bottom node. And so this is super important because if I had a whole bunch of these, again, I'm only cooking the one I'm moving, right? And the reason why this works out so well is because the replicator dat, it's not taking anything that cooks. It's taking the most static variables you can possibly take, just the raw things you need to like regenerate this stuff downstream, and it's feeding into the replicator. And if I go inside this geocomp, you'll see that It's actually, where is it pulling from? It's actually selecting that transform chop directly from that node. So splitting it and then selecting that data is a way of keeping it from basically forcing everything else to cook. So even though I've collapsed the data in a sense, I've re-expanded it and managed to keep things kind of isolated from each other, which is important at this part of the network because, again, it just comes down to cook control, really. So from static, I would say the templates are static, right? Because once you have a template, it's not going to change except maybe once every long while when you're making adjustments to it. But then you might get into some burst territory. So an example of this might be moving a color picker, right? You adjust your RGB value for color, and you're doing this in real time, but you're only doing it for a few seconds, right? Maybe a minute, worst case. So this doesn't have to be as optimized, but it definitely needs to be split apart from the static stuff because the static stuff can be the heaviest things in your scene. So doing SOP work, where you're generating a SOP or you're doing something with a SOP, like adding point attributes, you definitely want that to come before um, anything that's like burst or real time. And so that's kind of how I think about the networks. And when I split things up, I make sure that the heaviest things and the most static things happen first, and then I kind of keep applying stuff to that as I get all the way to the real time elements. Cool. So some other examples of the static and the burst. Let me see if I can find. All right, so fixtures. This is kind of an example where things have gotten kind of complicated, and I've had to find ways to optimize that take kind of two of these principles into account. So I'll just make a quick fixture again. Okay, so two fixtures here. So there's a few things happening here that kind of illustrate something I mentioned earlier about like collapsing. So there's a principle I guess I kind of talk about in here. See, it's this next slide. Yeah, so when you basically each of these fixtures, let me just kind of show you what happens when I move one of these around. It's the wrong one actually. So this is a little bit heavier, but you can see some of the same things are happening. So we have this transform here. It's getting it directly from that, and it's keeping it separate. It's staying up here. It has to at some point go into this container so that the pixel coordinates can be converted to real time or until it's a world space. And so it's merged into here, but the reason why there's just so much going on here is because all that stuff has to be split apart and kind of managed until the very end. So that's basically that. There's also these textures. These textures play a big part in routing, but again, I'll get to that later because that's more of an optimization topic. Cool. So as things move through the pipeline here, this section here contains mostly static, a little bit of burst, but also a few real-time things. You can see this is cooking because it's generating that instanced pix geometry. As you move downstream to the sampler engine, things get a little bit more real-time. Here we have a few static things. So we have our world coordinates for basically every single pixel in the project, which you can find over here. And this is happening through a GLSL top that's taking the coordinates that are in world space and it's converting them to screen space. And this is what goes to the sampler. This is basically what gets sampled kind of in 2D space. And so that's burst because you might be updating that in real time for periods of time. And then down here, we have the sampler. It's kind of a crazy area of the network because a lot of stuff comes together. It's the biggest consolidation of data in the entire software, really, because you have your coordinates, you have various masks and arrays, and then you have your content. And even the content is a collapsed example of like further stuff that's upstream. So to kind of show you, let me just make a couple clips here. Couple projectors. Not a whole lot of screen real estate, but all right, cool. So you'll notice here that this top now has two textures in it, and this is actually a 3D texture, or a 2D texture array, I guess. And the reason why I'm doing this is because I already have so many inputs in this GLSL that I really don't have much room left over for actual content to get mapped. So I'm taking 32 textures or fewer, depending on your GPU, and I'm collapsing them into one texture, and then that texture is going into the GLSL multi, and it's being sampled again. So there's a lot of like consolidation of data that happens here, and it's probably been the most difficult thing to optimize because it's just well, it's a lot of shader code, and there's just a lot of like trying to read through coordinate data and understand what it means on the GPU. So kind of that's where the static meets the real time, and then after that, it just stays real time for pretty much the rest of the software. Any questions or comments so far? Cool. So, oh yeah, sure, yeah, definitely, yeah, thanks. All right, so the last thing that happens in this entire chain, where pretty much there's no static, there's no anything that's real time, is the output module. So here, I'm taking this buffer, which is essentially 512 wide by however many universes tall, right? This is the result of all that consolidation, and it's being converted into a chop, and that chop is just going out to the devices through DMX and ArtNet and streaming ACN and all that stuff. So this is the end of the chain in GeoPix. This is where data ends. So it goes from the templates to kind of the scene geometry to that kind of expansion of data where like everything gets rendered and generated. It's the heaviest part of the network, but the entire purpose of that really is just so you can see and click on stuff on screen. And then after that, it kind of gets collapsed again, and then it goes out to the device outputs. Let's see here. Cool, so that kind of, I guess, ties up the editor. The next kind of area I wanted to show you was the I/O tab. I/O tab is, again, it's kind of like a miniature version of Touch. There's a few things in this that was different to set up than it was in the other parts of the software. So again, it's heavily reliant on clones. And there's a few things that kind of help set up nodes that automate things. So to kind of show you that. This is kind of the template section for the I/O. So I have a list of effects here, right? These are generative effects. You have a noise, you have a ramp. These are just things that you can find in Touch that I've built wrappers around, essentially, even though they're pretty much no new features with some of these. And when you make this module, when you have hundreds of these later on down the line, it's going to be difficult to make changes to each one. So I have this script here that when I execute this, it basically sets up the inputs and the outputs, and it manages the creation of all this stuff here so that it's easy to add new content on an ongoing basis. So that's a really important part of the I/O tab. In addition to that, I really took the context-based stuff to the next level. So in Touch, you know, we're all just used to it. You left-click to move the network view, and you right-click to marquee. But if you have a single node, just make a few nodes, actually. Oops. So if you grab one of these, you're moving it around. You'll notice you're not selecting it when you do that. If you move the one that's selected, it keeps it selected. And if you have two selected, and then you move this one, you're still not selecting it, you're still moving it. But when you move any of the selected ones, you're moving both. And I know this is like, well, yeah, of course, that's how Touch works. But thinking about them in terms of like context is a really interesting challenge because you have to figure out, well, what are the logical rules that separate this action from this action? Because in the end, you're actually, you know, at least in GeoPix, I'm executing different functions for each of those contexts. So you really need to know what it is you're about to do before you do it. And so again, it comes back to the render pick stuff. So creating something like that in the viewport involved kind of analyzing that and thinking about it because you only have, in the end of the day, a couple mouse buttons. And so if you want those mouse buttons to give you 5 or 6 different potential functions, you need to know how to split that apart into, you know, basically different different paths of logic. So that's something to really think about when you're building software like that, is the context of your actions and what do you want to do, because again, you only have a couple mouse buttons, so you got to make those count. All right. So there's been a few other things in the I/O tab that's been an interesting challenge. One of them was drawing wires and connections between nodes. So if I connect, let's just drop a composite. So you can connect nodes, and you can deal with things kind of like you would expect in Touch too. But this was a challenging thing to get right, because having all of these connections, there's nothing in Touch that inherently directly says, hey, this is a connection. I mean, you have ways through Python to kind of access this information through saying, okay, here's a node, what's its inputs? Is there anything connected to those inputs? What is that node that's connected? So it's a multiple step thing to get that information, which makes it pretty heavy to execute that in real time if you have a dozen or 2 dozen nodes. So this is a really interesting challenge that I solved through kind of a similar workflow I use in the editor, where you have a replicated network. So you're taking, again, this scene list, right, which is just the most simple data you can possibly get. This doesn't cook. It's just basically feeding the replicator. And inside of each of these items, I'm basically saying, hey, when this node moves, write this data. It does this locally, and then this replicated item is actually going to pull that select, with the select dat, it's going to pull it in to this network. So you can see this is just a select dat that's coming from the node. And the reason why I do it this way, again, is so that you can scale this up and really take it to higher levels. Because if you have 5 objects, 10, you might just be able to do a brute force approach. But if you have 200 or 300 objects, you need to be able to replicate those and have most of them stay static while the ones that you're interacting with update. So doing it this way with a replicator and selecting directly from that node allows you to separate things and keep things in like more of a decentralized manner until you need it to become like a group. So this allows you to kind of scale things up considerably. Obviously not as well as Touch, but it's a work in progress. So with all these nodes, you can move one, and some of the connections didn't carry through, but it allows you to kind of keep things basically as fluid as possible. So these wires, which are not all rendering at the moment, they pretty much come together in the viewport. And this is another example of just kind of how things have been optimized to put the static stuff first and the real time as far down chain as possible. So here we have the lines. And so we're taking that data that we merged from the replicators right here. And you can see that we have a bunch of coordinates. And so basically, I'm updating this script shop. And this goes right into a top. And this top goes into a very simple GLSL shader that's just basically moving the vertexes around, and the vertices it's moving around come from this this script stop. And the reason why I separated this off to the side is because generating this many points, 512, is just like a static number, because I don't think we'll have that many lines in GeoPix, and so that's generated once. We add things like vertex IDs through another relatively heavy node, and then that's done. It's not cooking anymore, and all of the heavy lifting happens to the shader, which is going to be much more quick and stuff like that. So that's one of those things that kind of just had to be done to get the numbers that I wanted in terms of connections and just things on the screen. So, all right. So the last tab, I guess, that I will talk about is the Perform tab. Perform tab's a little bit different than the others. It's a blank canvas, as I was mentioning before, and you can drop things onto that canvas and you can resize them. Here's a horizontal slider, and so these things can be placed wherever, and then once you're out of edit mode, you can just interact with them. You can connect these sliders to things in the I/O tab, and so there's some cool things you can do with that. But the main thing about this system that kind of was really cool that it worked out this way is the panel resize parameters. So you can take a panel chop and you can or a panel comp, and you can resize it and you can change its height. And so that's an awesome feature that was already built into Touch. And so I thought, how can I leverage this in a grid-based environment so that I can have some of the same functionality And so it's really quite simple. I mean, I just let the panel comps be editable in terms of their position and their size. Let's see here. Yeah, so the one difference is when you release your mouse, it's basically going to find the nearest grid size and it's going to snap it to that. And that's literally all I had to do. I just let the touch node, the touch kind of functionality work, and I just laid something on top of that. So a big fan of making things layered like that in terms of just, yeah, using what's there. No, don't reinvent the wheel, stuff like that. Let's see what else. Yeah, so things have to be responsive. That's pretty straightforward. The other thing about this UI is I broke from my other UI. So I have a UI system I kind of use for the most part in GeoPix, and this stuff here, the column layouts, they're its own thing. But a lot of this UI is just like standard comp UIs. But at one point in time, I was thinking, I tried really hard to make a UI system that worked for everything in the software, and you can spend a lot of time trying to reach that apex of perfection when it comes to UI. And what I realized at some point was like, hey, it's okay to split this up into a couple different UI systems, right? And so really, things are actually split into 3 right now. There's these super efficient column layouts. You have everything else. And then the perform system is like its own UI system. And the reason why is, for obvious reasons, when you're performing, you need this stuff to be, as fast as humanly possible, even at the expense of like other attributes of the UI. So again, it's really simple. And I ended up kind of branching off and doing a different UI system for that because it was just, a very difficult thing to get to achieve with other workflows. So that's kind of a feature of how things have evolved with GeoPix there. Let's see here. Oh yeah, so also the other thing about these is extensions. I've used extensions everywhere, but this is a good time to start talking about them a little bit more. So the way that this perform system works in practice is, you have the on-screen controls, but then you also want to give people the ability to map MIDI and OSC and maybe MQTT and various other types of inputs to these sliders. And so there's lots of different ways to do this. The way I went about it basically allowed the on-screen controls to always work, but then you have other sources of data that set those sliders and set those buttons to various states based on their inputs. So here you can kind of see I have a module for MQTT for keyframes, which is down here. Then we have a few other areas that this information can come from. And this was a useful way to break it up, but the problem here was that, when you're setting a slider, you're doing slider.panel.u equals a value, or you might be doing the .click function. So there's a couple different ways you might set a slider, but then what about if you have a button? Your button's going to be set with different logic, maybe even different functions. And then if you have a radio group, it's even more varied than that. So the reason I use extensions is so that I can say, hey, this UI widget, I'm setting you to 1 or 2 or 3, and it doesn't matter what it is because 1, 2, or 3 pretty much always will equal something on that widget. So in the case of a slider, I'll show you the extensions. It's pretty simple extension. Let's see. So we have set, and set there's a set for every module, but the actual contents of set is going to be different based on the type of widget you're setting. So for something like this, it's pretty straightforward. It's just a click. But something with something that's like a bank of buttons, for example, you might have a much more complicated set function. So I'll go and show you what that would look like for something like the button bank here. Okay, here we have another extension, and if I open this up, I believe it's this one. So this one's a little bit different. The set function is actually pretty big, and it doesn't need to be this big if all I was doing was setting by index, but one of the features I wanted to have was the ability to set the button based on the name. So if you have a bunch of video clips loaded into your UI, you might have names for each of those. And so if you set that, if you set the button bank by name, say clip 1, if you add more clips later, the index is going to change. So having a name option allows you to set it to the same thing no matter what your library is looking like. So Incorporating that in the set gave me essentially a way to set everything, either through a string or through a or an index, or however I wanted to set it. And of course, there's some logic in here to determine, is this an int or is this a string, which is this part right here. And that's been a really helpful thing, because now all these different modules can control the UI at the same time from different sources, and it's a very simple kind of code paradigm to kind of like keep in mind. So that's been a really helpful facet of setting up these UI modules here. All right, and that's break, I guess. So. All right, I guess we'll keep going if you guys are ready. Is everyone good? Cool. All right. So diving into kind of the last section, I think this should be, interesting, because I would like to touch on the UI stuff that some of you are interested in. So I guess the way I approach UI now, or at least the way I approached the very last component I built, was by kind of asking a set of questions. And these questions were, some of them are pretty obvious. Most of them I would say are pretty obvious, but I figured it's just good to kind of like break it down anyways. So is it feature rich? Can you do lots of different things? So, with GeoPix, I can scroll to adjust the value, which is great for things like translates. But also, can you use menus? Can you reset it back to the default? Can you map it? Can you do all kinds of things with it? So that's an important question, but it has ramifications, obviously. The next one is, does it have good real-time performance? So like for the thing I was just showing you with the performance system, it's really important to have that real-time performance above everything else. So next one, is it network heavy? This is probably the biggest one I've struggled with over the years, is making something that can be replicated quickly. Honestly, I felt like I haven't even solved it until recently, and I'll kind of explain to you my workflow using the web render top, which is pretty cool. Is it responsive? That's a pretty much a no-brainer. You want it to be responsive, because you're going to change stuff eventually. Can it be styled? This is why I didn't use the parameter comp, because I love that thing so much. It's fast, but you just can't style it. And there's a few things that make it a little bit finicky to use for like a kind of a front-end software where you want it to look like its own thing. And then the last thing, is it modular and reusable? So that's just really helpful when you're, populating UI throughout an entire network and you want that thing to be updated. Does it update easily? So those are all good questions to ask. And depending on what you're doing, you may not care as much about the modularity. You might not care as much about the real-time performance, and you might not care too much about the features. It really just depends. For me, in my order, it's kind of like generative performance, meaning how fast can you build that UI in real time? That's super important to me, because I want people's experience in the software to be fast. So when they click on something, it's got to change instantly, not over time and not with a lot of lag. Real-time performance is pretty important, but for most of the stuff in the UI, this stuff, it's pretty fast. Actually, nowadays, or now with this web render top, it's very fast, but it didn't actually need to be. It needed to be just kind of decently fast, because this is only stuff you're using when you're authoring your project. Responsive layout, again, no-brainer. Different ways to set values. This was really important to me as well, because if I have something like a primitive, I'm going to be adjusting this through a menu index, whereas with the color, this is a float slider, right? And maybe I want to double-click on here and type in a number, and maybe I want to increase this more quickly, or I can use Control and Shift to like speed up or slow down the rate of change. So there's a lot of features baked in, including this like tooltip thing. So I can click on this, and it pulls up a help documentation from DAT somewhere that's stored. So this is very useful for giving people something that's not quite a web page, but more than nothing. So that's been really helpful. Different ways to set value. So yeah, that's kind of the order I've prioritized things in. So this is a good opportunity before we get to this one. Yeah, so if you open up that example file, this will be the first example we actually dive into, example 1. I'm going to go ahead and open it as well. So it's the Summit 2019 LSSA examples TOE. Should be the only one in there, I think. So if you go into EX1, this is a very simplified example of the kind of the concept I was describing earlier, where you have data stored somewhere and you have your UI, and when you interact with the UI, it's kind of like this non-linked bidirectional thing. So in the middle here, we have this thing called some object, and you just have custom parameters on here. And if you move them, you'll see that the sliders are moving as well. And I just threw a parameter comp over here so you can have something to kind of work with. But if you go inside the container called UI, you'll notice that the, well, hold on, let me actually pull up this parameter window. So if you adjust these, you'll notice that just like I was showing you earlier, we have these values changing on a per widget basis. So these aren't all updating at the same time. I've got this evaluate dat, which is basically parsing out the names of the custom parameters. So this is kind of like the OP find, right? It's accomplishing the same thing, and it's essentially building a list that doesn't update often at all. And so if I go into item 0, for example, you'll see that this value is actually being extracted from the parameter with a parameter dat. And this is quite useful. I love the parameter dat. It's a new addition, and it gives you virtually every piece of information about that parameter, including section and min, max, and everything, really. So you can use this to completely generate your UI without any kind of finicky Python stuff. It's great. So for example, if you look at the slider underscore GFX, we have a TDU remap function. And I'm just taking the value and I'm mapping it from their normal min and max to the width of the parent. So this makes it possible to have a slider that's always moving between the min and max of the widget, and it references the min and max of the custom parameter. So you have a one-to-one representation of that, so to speak. In addition, the panel execute left select. This is a very simple script that basically lets you set the slider with the UI. And you can kind of see the kind of concept here. I'm basically grabbing the panel U, I'm remapping it into the range that I know that parameter is, and I'm just setting the parameter with that value. So this is basically setting the parameter, and the parameter comes back through this, and it sets the graphic. So it's just that same concept I've been talking about there. Cool. So that's basically all there is to that example. It's just a very simple example of that concept, and then I've kind of expanded this in the UI system I use in GeoPix. So I'll actually show you guys that next. If you open up the leftmost container, it says UGV4. So this is the web render top UI that I've been working on, and I think you'll have to go into project 1 as well. And so the way this works, there's a lot going on in here, which I'll talk about in a sec, but in terms of using it, it has extensions, and all you have to do is run any one of these scripts, and it'll basically update the UI to reflect what's going on in these custom parameters. So the yellow and the orange are 3 different groups, and you can kind of test each one individually, and you can see how fast this updates. It feels like basically instant. And the problem I had before was that you'd have a dozen or 2 or 3 dozen widgets, and they would replicate over the course of like maybe 300 milliseconds, so it was pretty heavy before. But so once this thing generates, what it's basically doing inside of here is it's taking the object and it's looking through all the custom parameters using this parameter dat, and it's generating essentially it's generating a whole bunch of HTML. So if we look at the HTML, let's generate a simple UI here. Let's see which one's smallest. All right, so this one here is pretty small. And if we look at the HTML, you'll see that we have, I won't go into this too deeply because it's a bit dense, but you have a widget container, and then you have a widget label, you have a tooltip. It's basically just a tiered hierarchy of HTML elements, and this kind of structure is paired very closely with the JavaScript that interacts with it, because when you hover over a certain element, you need to know what that element is you're hovering over, but also you need to know what's the next element in the list. So when you hit tab to go to the next field, that's what that feature is for. So anyways, if you open up the parameters for this thing and you just hit regen, you'll see that we're basically regenerating the HTML. And that's how it initializes the UI. It basically generates it from scratch. That's not quite as fast as it could be. It's not slow, but it's pretty quick. But when you actually go to interact with the UI, you're actually well, it's not working. That one is. All right. Weird. So when you adjust parameters, that's when you start using some of these other chops or chop executes down here. So we've got the hover, left select, right select. So each of these basically handles a different mouse button, different context. You have the mouse scroll, you have the double click, and the delayed tab. So all of these things you can use in the UI. So if I double click on this and hit tab, I go to the next. And the only reason I know what's next is because I'm extracting that through JavaScript and the web render top. And the way things are extracted from the web render top is a little bit of a hack, but it actually works pretty nicely, and it's very simple, which I like. So when you hover over things, you'll notice that this DAT called web info, we're actually pulling a few things here that's being shoved into the title element, which is the only thing that I think you can extract at the moment. So we have the parameter name, which is RGBA-R, and then we have the bounds of that actual thing. So if I were to double click on this and have that field come up, these bounds actually help me place that field right over top of that element. So I'm actually not editing the HTML. The field comes on top of that, and then when I submit that, it goes back to being off. So in addition to that, we have left 2, top 2, right 2, bottom 2. These are all basically bounds for the next element over. And then we have X and Y, which is strictly where your mouse is in the X and Y space of that div element. So with this information alone, it's kind of like a render pick, right? You have this information coming out constantly, and then all of these functions here tap into that, as well as the panel that you're clicking on, which is just one panel. And then from that, it extracts everything it needs to do modifications to the parameters, and then again, that comes back and it impacts the web stuff through JavaScript. So to show you the way this is styled, if you want to use this in your own projects, see here. Cool. The way this works, you have the top and you have the bottom, and the top one here is going to be your CSS. So this is actually pretty straightforward to edit. You can just go in here and tweak things as you would like. There's quite a bit of CSS in here, but the main ones to worry about are kind of in the top half. And as far as the JavaScript goes, it's down here in the one called BOT, bottom. And this is stuff you probably don't need to mess with, but if you were to add functionality, this is how you would do it, in this kind of area here. Let's see, JavaScript. Yeah, so what this basically does is there's a few functions. There's the mouse, which basically sends the mouse coordinates in, which is what helps the render pick situation kind of generate its information. And then there's this thing called update, which is maybe it's up here, somewhere in here, set drag overlay. Yeah, update. So this actually handles some different things as well. And this is actually what places the render pick information in the style element for the HTML DAT. So that is all of the functionality that pretty much updates the web page when you drag stuff in real time. That's all JavaScript. So with those things all kind of working together, you can pretty much have a UI that works very quickly. And this is all working on a different thread of Windows too. I don't know if you are all aware of this, but if you go to your task manager, just to kind of show you, I have a whole bunch running right now, I guess because I've started and stopped things a lot, but each of these is its own thread. So it's rendering the UI off in a different thread, and it's bringing it back into Touch, which is great, right? Because multi-threading. But now with the engine comp that just came out and the experimental, who knows? I guess this is all kind of changing things up a bit. But so yeah, that's pretty much all there is to say about the UI. It's kind of solved all of those challenges that I kind of named a second ago. So is it feature rich? Yeah, it has the same features I had before, and it also works really well in performance in real time. That was not actually a prerequisite. I didn't care too much if it did, but it actually works pretty well. The network is not that heavy because it's one top as opposed to like hundreds, right? Previous UI, every widget I had could have been like 100 operators of various types, and that adds up a lot when you're replicating stuff in real time. And it prevents you from making like complex objects that give you lots of like dials and knobs to dial in. So yeah, it kind of checks all these boxes for the most part. Yeah, it really does. As far as the modularity, it's quite modular too. I can pretty much update the talks, load it in, and everything kind of updates from clones. So I'm pretty happy with this, and it was only because I was able to basically batch all of those UI operations into one top that really made it fast. Until then, I just kept pushing the problem around. I either had it working fast or I had it feature rich. I never got all of those things kind of working together, and so this is what really helped is batching the UI together instead of separately. So that is it for that. Okay, the next thing is optimization. This is probably the biggest topic. I've brushed on a lot of these things kind of in the first part, so some of this will seem familiar, but architecture choice. These are kind of the main things I tend to look at when I think about optimization in Touch. I think about like the architecture choice, which means, you know, am I working with objects that later get consolidated, or am I working with like a table which later gets split? And the problem with the latter is that everything cooks downstream, but there's apparently some features coming out in the near or somewhat not too distant future where each chop channel may have its own independent cook dependency, which is going to be a game changer if that happens. Some of this stuff won't even matter anymore. But until then, you know, I kind of tend to think of things as like, all right, is this going to be merged at some point? If so, how long can I keep them separate before I merge them? So when it came to the objects in the scene geometry, right, things are separate here, so they're decentralized, and they stay this way all the way through till the end of this. This is where things kind of get merged together for the viewport's sake, and that's kind of an important thing to think about. Even inside of the fixtures thing, like I was mentioning, you have all these tops that take a whole bunch of textures, and it compiles them into one texture, and then even those get compiled again. So we have a lot of consolidation that happens over the course of a few steps in the network. Really, everything comes together for the sampler engine. Everything that impacts the way something looks on screen or goes out to the LEDs has to be inside this module, which is why this gets so crazy and we have so many inputs. And you know, this will be a work in progress. In like another 6 months, this will probably be even more optimized and more consolidated. You know, I got to find ways to scale beyond a certain number of textures. That's currently limited. I think 32 is like kind of where things are at. If you have more than 32 video sources, you probably have other problems too, but you know, it'd be nice to have like generative textures and stuff like that that could allow you to go beyond that. So all right, the next thing, static burst, real time. I mentioned this already, so I won't kind of go into it again, but splitting things up. This is actually, okay, yeah, I'll come back to that. And then C, expanded versus contracted. This is kind of, this kind of goes hand in hand with A, right? Because when things are expanded, you can address them individually. When they're kind of contracted as one, that's more difficult to do without causing downstream cook times. Caching data, so I'll go into an example in GeoPix where this is leveraged heavily, and it's actually the indirect illumination. So I have, you know, thousands of pixels. How do you consolidate that down to something you can render in real time through deferred shading? So I'll show you guys kind of what I came up with there. In terms of node count versus cook time, there's not too much to say here. I guess there's some situations, rarely, where like I prefer to have more cook time over more nodes, because if it's replicating and generating dynamically, I'd prefer it to like happen quickly and then have a little bit of delay if it's like a burst type channel. So that's something I think about a little bit. And then, of course, I think we're all familiar with the CPU to GPU data rotation. So if you have something that's the top, and you go top to chop, and then you go chop to top, you want to avoid those rotations going back and forth because that just eats up and stalls the CPU and GPU depending on what you're doing and where you're going. So that's kind of the categories I guess I could think of when I thought about all the things that I tend to run into in optimizing. So I've kind of mentioned this, but this is a good chance to go into example number 2 in the toe. And this is a very simple example, but it illustrates kind of the idea of the centralized versus decentralized data structures. So over here in the top, this is kind of how I have things set up in GeoPix. We have object 1, 2, and 3, and maybe I'm transforming object 2, right, or doing whatever to it, and it's cooking constantly. But objects 1 and 3, they're fine, and then things get merged afterwards, and then the instancing happens kind of at the right. The way I used to do this, and the way that kind of didn't work out so well, was I had a DAT table, right, and I'd update this DAT table. It's super easy to manage a DAT table. You can manage undo, redo very easily, but you have other problems like everything cooking, and this might change in the future for derivative, but at the time, or at the moment, this is kind of a big problem. So I try to avoid this at all possible. And if I have this DAT table that's replicating, which you saw a few areas that did, I just make sure this is as static as possible. So that's kind of my main thing there, and that's it for that example. Cool. So this is just another example. This has to do with a static burst real time, and this is example 3. So this is pretty self-explanatory as well, but you have things like this ramp. Generating the ramp is probably the heaviest thing you'll do, even though it's not that heavy. It's just a ramp. But these things are going to change very infrequently. So I have the toggle in the menu, changing the style of the ramp. So if I change this, it's just going to make it look different. And so I want this to happen infrequently, and I don't want anything else affecting this chop channel to cook. So that happens first. Color is a burst parameter, right? So I might change the color periodically, and it might happen in real time. But having that just after the static stuff is like a good way to kind of keep things from forcing this to cook again. And then last but not least, you have your real-time stuff, which might be a rotation, it might be pixel mapping, it could be whatever. And just putting that as far downstream as you possibly can is the best thing you can do for optimization speed. So that's really it. That's a very simple example and a simple concept, but I think about it constantly. So there it is. All right, so expanded versus contracted. This kind of, like I said, has a lot to do with how you organize your nodes and your operators and your containers. But a good example of this, is where is it? Okay, it's going to be here. No. So there's a certain step of the pipeline in GeoPix where your world space coordinates of all your pixels need to be converted to screen space so that you can sample them. So I was at one point doing this in each container or each object, but the problem with that is you have overhead associated with that, and you don't really need to be doing those things in like their own containers. So what I did was I had all the world coordinates here. So I'll go ahead and oh, nice. All right. Well, crashes happen. Start that back up. Cool. All right, so I'm going to make this fixture again and just do a quick array. Let's see if I can get back to the slide we're on. Cool. All right, so the thing I want to show you here is if I had 2 of these fixtures. I kind of mentioned this earlier, but there's 2 steps that kind of bring all this data together into one buffer. The first thing that happens is in type 2, which is for the fixtures. You have your coordinates, kind of all your coordinates, your XYZ values essentially get compressed into this. So every fixture is essentially creating a buffer of universes and channels. So it's basically a texture that's 512 wide by however many universes tall that is in your entire project. And this is important because since they're all being merged, they have to be the same shape and size and dimensions to get merged downstream. So starting in the fixture, you can see I have routed chords, but most of this is black because the fixture is only kind of taking up this amount, but you have to account for the entire buffer in the original piece of texture. So that's coming out, and it's getting merged down here. And this is basically, it's almost like, the best way to think of it is like a composite top. You're taking each layer and you're adding it to the previous one. It's a little bit more complicated than that, but that's essentially the gist of it. And then because I want people to have the ability to create more than 32 fixtures, right? And some AMD cards are limited to less than 32 inputs. So it's really important that this is able to go beyond that. So to go beyond that, I actually have a staggered approach where there's 4 GLSL multis, which each take in up to 32 inputs, and then we combine that again, so we can take in 32 times 4, whatever that is, and this ends up being the final buffer that all gets placed in. And then once you have this buffer, even if I'm moving a fixture, right, it's limited in terms of how many things are going to cook. So this is very useful, and it's just very scalable because textures, there's a little bit of overhead to GLSL textures, but it's better to have one of them and just lots of data inside, because once you do that, you can scale it up really far. And so anyways, these coordinates are not the only type of coordinates. We have some masks, we have some auxiliary information, and just a lot of stuff that comes out as textures here. And so the second time all this comes together again is where I showed you earlier in the sampler. So we have the coordinates, and there's actually several versions of coordinates. We have the standard ones, we have some shuffled coordinates for like noise effects and other things, and all these things are cached and static so that we can fade between them and interact with them in the GLSL shader, which is cooking. It's very low cook time, right? Because in the end of the day, it's actually not sampling that many things because there's only a handful of pixels in here. Even though there's a lot of pixels in the inputs, it consolidates extremely to an extremely small size, and then from there on out, it's a pretty lightweight network. So that is an example of where, you know, I took computation that was at one point happening per object, and I kind of moved it downstream after the collapse because that's just a more efficient way to do it. And sometimes that's not the case. Sometimes you actually want to do things on a per object basis because you don't have GLSL or you just can't do it quickly. So it really depends on what you're doing. So caching data. Okay, so this is a good opportunity to show you the global illumination thing. So let me open up that project I had. Am I loud enough? Everybody can hear me okay? Cool. All right, sweet. So we got this scene here, and just picking up where we were at the beginning here. So there's the way to look at this problem is you have a point cloud, right? Essentially of LEDs. In this case, they're all RGB, but they could be other things as well. But this essentially is a static cloud of coordinates, but then the RGB values, of course, are dynamic in real time. So the challenge with this was to render illumination out onto the scene, because you want to be able to show clients and even just show yourself what something's going to look like before you deploy it, at least as close as you can. And so the challenge was, how do I render this many lights? Because if you have light comps in TouchDesigner, you know you can't make more than like 8 before your system's going to struggle, and that's primarily just because forward rendering techniques just don't scale like that. They're not meant to. They can't. So one of the ways you can get around that is through deferred shading, which if you guys have, I'm sure you've probably seen Matthew's tutorial on this. He has a really good tutorial on it, and there's some stuff floating around the forums and on the web and GitHub where like people have basically created an example. And so I took that example and I thought, okay, this actually works really well for 200 pixels, maybe 300, depending on your hardware. But how do I make this work for like 2,000 or 3,000 pixels or 20,000, right? And in this case here, I guess we have 100 times 8, so this is 800 pixels. And so my solution was to, you know, create a simplified version of this point cloud, you know, because if you think about it, you have maybe 15 pixels right here, and maybe for visualization's sake, you really don't need to show each one's light output. You can really just show the average light output of this entire group, and then you can put a light at the average center of all those pixels. And this is actually what we're doing. But the problem with that is, how do you place those average light coordinates, right? You see, if you're going to have 3 per arch or something like that, like, do you specify that manually? Do you have like an algorithm? And so fortunately, I was able to get a really cool Python library called sklearn. I'll just pull this up real fast so you guys can see it. So if you look into this, it's, you know, installing and getting modules set up in Touch can be a little bit tricky, but once you do get it set up, this is an amazing library because it works in n-dimensional space. You can use it for 2D, 3D, other stuff as well. And basically you feed it coordinates and you tell it what kind of classification you want for your points. Do you want it to be, I mean, this picture here shows you all the different ways that you can cluster data. And to kind of explain that, if you don't know what I mean, if you have a point cloud and you need to know, like, say you want 5 groups out of that point cloud, this library will let you essentially specify your point cloud as a NumPy array and then how many groups you want. And then it outputs basically a list of coordinates or indexes of the coordinates of each group. So Using this library, I was able to essentially generate these clusters automatically, fairly easily, without having to think about it too much. And the way this works, if I go into settings, there is a section called indirect illumination. Right now I have 256 light clusters, and so this looks pretty good. But if I went down to something like 8, it's going to think for a second. It's got to recalculate. And you can see that, for one thing, I need to have my brightness up because there's not as many lights. But you can see there's just not much resolution here, right? We're getting a little bit of flicker here and there, but it's just not very great. And that's because the algorithm is trying to find the best cluster situation for this many lights, but there's just not that many good arrangements that accurately portray reality. So this gives people with the capable hardware to kind of like push things to a higher degree. And so that's kind of how it works in the front end. The way it works in the back end in terms of implementation, this is in the viewport. So let's see. So with deferred shading, as you may know, you have to render out a subset of passes from your geometry. So you need surface normals, you need XYZ position, and I think something else. Maybe it's depth. Can't remember. Anyways, you render this. And then with that, there's some GLSL code. And this is stuff you can find, some pretty good stuff for TouchDesigner online. So I'm just going to show you the implementation of it. We have our world coordinates here, TX, TY, TZ. And this is basically being fed into the script here, which takes this as a NumPy array. It feeds it into the clusters algorithm, and then it outputs a bunch of centroids for each group. And so that's what we have here, right? This is being written to by the script where we have a bunch of IDs and a bunch of centroids. And so these centroids are basically the coordinate for each of those actual lights that output light. And then with this replicated network here, we actually split up our coordinates and then we recombine them into a different layout, which is important. So each of these rows of this texture is essentially a cluster of lights. And so I think these are going into a shader here, which basically calculates the average pixel value for each of these, and then that goes on further downstream. And this light information basically feeds the GLSL shader that actually calculates that light output on the normal and on the depth stuff. So really, it was just a matter of taking those two things, right, that library and the examples that you can find out there, and meshing them together. So really, it's just a matter of getting your coordinates out of a texture versus other places. So here you can see the passes. We've got position, normal, maybe that's depth. I think that's depth. And UVs. I don't think UVs are being used, but anyways, that's kind of how that's handled. And so the cool thing about this is that you don't have to be able to render that many points. You can simplify it, and it still looks pretty nice in the viewport. So. And so the caching, the part of that that's caching related is obviously the clustering. So this information here, depending on how big your scene is, I've had this take 10 seconds to calculate. You know, it's got to think, but once it's done, and you don't have to worry about it until you move a fixture around. So I have this this thing that detects movement. So if I move a fixture or edit it in some way, you'll see that this button up here turns red. So it's basically saying, hey, you need to recalculate your lights. And when you do that, you know, you're going to get your light now in that position with the clusters, and there you go. Another but less extreme example of this is with marquee select. So with marquee select, you're taking 3D coordinates. This was a really interesting thing to work out. It's most obvious with like a collection of pics, right? So you can marquee select. And this is, you know, I take this for granted for sure all the time in like softwares that have it. And then when I go and try to click things manually, it's like, oh man, this is terrible. I don't want to select 200 things manually. So to make this work, I needed to take these coordinates, which were already in world space, and I need to take them into screen space. But this is a CPU-bound process, so I need to do this differently than GLSL. And so to get this in screen space, I use the TDU.matrix modules along with the TDU.position, which lets you convert things through a pretty simplified Python code that derivatives put together. It's awesome. But the thing is, since this is CPU bound, and depending on how many pixels you have, this is a pretty beefy operation. By beefy, I mean it might take a second, maybe 2 seconds. And if you're dragging and you're getting a second, you know, if it's like 1 frame per second, it's going to be painful. So what I did was, when you enter marquee mode or certain other functions too, it basically bakes the coordinates to screen space once, and then you're just dragging and you're selecting, UV values, X, Y, and that's all you have to worry about. So caching that when you enter the mode, and then allowing the real-time parts to be only what's necessary really made that possible. So that's just another example of where caching really came in handy. So, all right. Kind of mentioned this. Sometimes I prefer to do, fewer nodes with a little bit more cook time. There's not too many situations where this comes into play, but it's a good argument for developing C++ plugins, because then you get best of both worlds. But that's a whole world of its own. So, it's just another thing to learn, I guess. It's not something I've really gotten into much yet. I'd like to, but there's a lot there. So, okay, the last example we can look at, and this is again something I'm sure you've all run into, but it's worth looking at. TD Summit. It's example 6. And in example 6, it's really just kind of showing you what happens when you have data on the GPU, goes to the CPU and back to the GPU. And if this cycle continues too much, it really eats up a lot of performance. And sometimes it's like impossible to avoid, right? Sometimes you got to go back to chop land, then back to top. Avoiding it at all possible is definitely a plus. But down here you can see, so this is just an example where, say I was applying some logic to this information in chops. I found it easier. I want to basically color the darker pixels with like a gray that's flashing. The same result can be, achieved in GLSL. It's obviously something you got to learn and figure out, and sometimes it can be more complicated, but it's definitely worth it, because the cook times and the performance increase is, you can see it right here, but in bigger systems, it's just a night and day difference. So, okay. So yeah, so coding in GeoPix, I have a lot of Python, and I'm going to show you kind of some of the places where that lives. Roughly 40,000 lines, I think, is Python. It's really grown over the time. I mean, it's just how I interact with the objects and the data, and since everything's wrapped around a Python function, you just kind of have to approach everything that way consistently. So down here, I've got this mod functions container. It's far too big, but down inside of here, I basically have kind of categories of scripts, and this is, I guess, the primary location where code lives. I have this thing called TD utils, which is basically just going to provide me with a lot of functionality in GeoPix that helps me. I do various things. So, for example, outliner sort. This is a very simple function, but I was running into an issue at one point where I was sorting objects in the outliner based on name. But you know how it is if you have object 1, then object 10. Those things don't always sort correctly because of the way like strings work. And so what I had to implement was like a natural sort algorithm, which once I implemented that as a function, I could apply it to, sorting objects in the outliner, in the scene, because when you select stuff in the outliner, you want your selection in the viewport to match that. So if you do a function where the first object's parented to the second, if that's reversed in the function, you have issues. So this is a place where that kind of stuff lives. It's just a bunch of different functions. We have a parenting function, an unparenting function, which is going to work with anything you have selected pretty much. And this just kind of goes on. You have selection, deselection, invert selection, even simple stuff like that I could have just done at the other end where I was calling the script. I was like, this would be a good thing to do in a function because other things might need to call this code down the line. And when you have that set up, it's easy to implement and scale your software. So I have 3 or 4 buttons that might do the same thing, and I don't have to go and update the code for all 3 of those places. I can just update it once. So that's been a really big help. So there's just a lot of stuff in here for, let's see, this one is duplicating. Duplicating is complicated because if you duplicate an object, the name changes. And so you have to kind of rewire things, but with a new set of names. So there's a lot of like translation and stuff that happens there. So anyways, just a lot of things here. There's different categories. We have save load, editor utils, geo info. And so this kind of just grew over time into a big library of things that interacts with GeoPix objects. The other place that has a pretty good chunk is, as I've been mentioning, a lot of the shader stuff. Probably the biggest thing is the world to screen space stuff. This was like a learning experience for me because I had no experience with matrix math before this, and I was like, well, I got to figure this out if I'm going to make this thing run as fast as I want it to run. So let me see here. And so I have this. Basically, this library handles like each individual matrix thing, and essentially you have a transform function, and this is stuff you can find online. I had a hard time parsing out what I saw online, so I had to really like make a verbose, very well documented thing for me because I would forget this stuff or I'd get it wrong. So anyways, all this stuff helps me take points from world space to screen space to world space, basically all the different directions you might need to go. And I can do this in Python as well. That's obviously not as fast, but I have kind of a version for each kind of world, CPU or GPU. And then the last thing in the code section is probably the hulls and pixels. So working with pixels is quite a there's quite a lot of code that goes into that too, because when you have these things, when you're dragging it around the screen, you're actually dealing with screen space, but you actually want to be positioning it in world space. So you have to like kind of figure out the math for that and kind of go back and forth. I have other things like some different kind of shortcuts for selecting things. You can kind of move that selection along, like snake. And so all these things kind of require different Python functions, and it was much easier to kind of bind this to a function and then call that function than to come up with a way to do it uniquely, maybe in SOPs or elsewhere, because end of the day, likely that something else is going to need to do this functionality as well from an outside source. So lots of Python kind of going on in the Pix manipulation as well. Cool. So last slide here. First of all, is there any questions about this stuff? Cool. Yeah, bundling this. I mean, I don't know how much experience people have had with bundling. It's pretty straightforward. You put everything in a folder, relative paths. That was all, fine and good. In terms of preferences, I have this thing that turns out pretty well. Let me see if I can find it. I save preferences in a different location. So if you uninstall and reinstall GeoPix, those things kind of persist between sessions and all that. And it's a very simple version of that. Let me see if I can find it. What I'm basically doing, and the reason I'm looking for this is because there's a file or a folder that Touch has a variable for. It's like a local, oh, here we go. Key. Yeah, okay, so, all right. Yeah, so app.preferences folder. This is just in the Python docs. It's a great thing to use if you're ever storing preferences because you don't have to worry about, is this folder on somebody else's computer? It's just going to be on their computer. And I guess Touch resolves this in its own way. So that's a great place to save like a configuration file. And if I open this up, it's just simply a JSON file. There's actually nothing in it right now because I haven't saved any preferences, but if I did, this would show up here. So for example, when people have installations and need to start automatically, this gets updated with the path to the right project file. And so all I have to do is launch GeoPix, and if it sees this and it sees the right information, it's going to start that up for you. And that's pretty useful. Let's see. Python, again, installing external libraries can be a pain sometimes. I actually don't use the method of going into the preferences and trying to fiddle with this. Because I don't know what other people's computer situations are going to be. So what I do is I just bundle the Python folder with the actual installation, and then I edit system or sys.paths, which is the Python. You import sys for Python, and you just go and say the very first path should be the one to the bundled one I included. And so it's going to check that first. You can also do it last, I think. Depends on how you want to set it up. But that seems to work pretty well for me, and so I've just been doing that for quite a while, manually editing that at boot. So when GeoPix starts, the very first thing it does is it sets that path so that any code that imports a module that should be bundled, it knows to look for that in the right place. So that's pretty much all that is doing. And as far as the installer, so when you get GeoPix off the web, it comes as like a .exe, and it can come as like a bundled installer where everything's included, or it can come as like a downloader where it downloads what it needs from the web. So this was, I'm sure there's other options out there. I didn't look too far. I found Advanced Installer, and I found that Derivative uses this for packaging up TouchDesigner as well. And I was like, cool, this is a great thing to use. I mean, what they do, I can do as well, and that seems like a good thing to kind of like have parity with. So I'll just show you briefly what it looks like. It's not cheap if you're gonna buy like the lowest tier that lets you really customize much. It's the professional one, but free version lets you package up stuff. This is a great piece of software. I mean, it's definitely worth the money for me, because what I wanted to do was release this as an installer that somebody could kind of install without any knowledge of touch, right? They don't have to like worry about downloading this and that. So, I can basically package files in here. I can create shortcuts. And what's really cool is I can add TouchDesigner as a prerequisite. So if it's not installed in the system, it downloads it and then it installs it, and I can set it up to all happen automatically with one click of the UAC or whatever elevation prompt. And so that's nice. It's just little things like that that really make it feel like a polished piece of software. And there's lots of other stuff in here too. I haven't even messed with like probably 95% of this stuff, but this isn't actually the project I have. It's just the empty application. But yeah, it's great. Probably other ways to do it too, but that's nice. So cool. That's pretty much it. How are we doing on time? We got 5:02. Is anybody trying to get out of here? You guys got a few more minutes? Cool. Yeah. Oh, yeah. That's a great one. That's actually the first one I was going to go into if there was time, was saving and loading. So I use JSON as like a format. I love JSON. It's just simple. Yeah, you called it, yeah. So yeah, that's a great one. Let me actually show you guys how that works. So here in this giant collection of code, there's a particular module for saving and loading, and this works in tandem with other modules. So other modules have their own save load. So for example, if I have the OSC manager, maybe I have some settings I want to save. I have my settings tab. So each of these have their own save and load methods, right, in the extension. Actually, let me pull that up so you can kind of see. I'll go ahead and show you the settings tab. It's a pretty simple example of that. So here's the extensions for the settings, and if we look down here, there's dict to JSON, settings to dict, which is basically a way of taking all of these values and assigning it to a dictionary. And so this method is called from the master save load, right? So I have the ability to save and load individual modules, or I can save the entire thing, and this is of course just manually mishmashed together. So I have basically all of these dictionaries being pulled in from various modules, so scheduler, time bar, pixel frame editor, UI mapper, MIDI mapper, all that stuff. So I'm creating a master dictionary of all of these sub-dictionaries, if you will. And so I'm using TDJ JSON to text. I think you could probably use the JSON dumps folder too, or method. I think that will also work. And so basically, I'm just writing that to a text file. So when I open a save file, let me go ahead and show you. TD Summit. Yeah, so when you open this in Notepad, it's really just a big long list of ASCII, and so each of these items, except for the ones with underscores in the beginning, that's like a special variable type. Like parent is not like a variable; it's actually a thing you have to do. So most of these are just custom parameters, though. So I have a parameter name and then the value, comma separated. And so the great thing about basing it around custom parameters almost everywhere in the software is that saving loading is the same everywhere, really. So when I load stuff and when I save stuff, I iterate through the custom parameters. I actually filter my page names. So I have these pages. Some of them are savable and some of them don't need to be saved. So I actually use all caps to signify that this is a configurable user-facing kind of set of parameters. So for every object that had, for every page with all caps names in every object, it saves essentially all the data to a dictionary, and it just dumps that into a text file. And loading is basically that in reverse. So that's how the saving loading works. Cool. And then so resetting the software to vanilla. So when you're programming, you do all these things, and you want to make sure that the user experience is the same every time you make a new build. So this is at least the case for me. So I have an area in here called startup scripts. And I don't really need to show you this too much, because what it does is it just goes through every module. Most of them have a reset function. So in terms of save and load, I can reset each module to its vanilla state, which is very simple to implement once you kind of have that set up per object. And I'm kind of cheating. I have a few in here that are actually like, very old code like the camera in the viewport. I'm setting it manually. I should actually, be using a reset function, but one day I'll get that set up. So anyways, I just run these scripts. I go down the line, 1, 2, 3, 4, 5, 6, and the last one saves out the toe and it puts the password on. And then I open up Advanced Installer, I click build, and there it is. It's ready to go. So it's a very streamlined build process that sometimes has snags when I add a new feature, and I need to make sure that's accounted for. But that's kind of the process there. And then literally the last couple things, some cool stuff I have cooking, and I'd just like to show you and definitely get your thoughts on it, because this is stuff I haven't thought about too much, but it's interesting for sure. So I'm kind of going to go in reverse order here. So clustered deferred rendering. Has anybody heard of that before? It's like a type of lighting protocol in terms, it's used in games a little bit. Basically, it's a better version of deferred shading, which is a better version of forward shading if you're trying to get lots of lights, really. If you're trying to do lots of lights, this potential method can scale really far. Like, I mean, I've seen some tech demos online where people had 2 million lights and they're still at 60 frames a second. Now, mind you, there's no shadows, and those lights, there's limitations, right? Because clustered deferred is essentially just an optimizing algorithm on top of deferred shading. So instead of like every light being calculated against every pixel, you're saying, well, this light is not that close to that pixel in real life, so let's just discard this calculation. So it's a way of basically optimizing the same method that's already being applied. And it's incredibly fast. And it really depends, though, on your light. So if your light has a radius of 2,000 units, and every light in your scene does, you're not going to get any gains from that, because it's really about small lights affecting, local areas. So that's something I've just started researching, and I want to start playing around with it and see about maybe implementing it, because that would give me the ability to actually not even calculate these average clusters. You just per pixel, you could just simulate your LEDs. That'd be wild. So the other thing that would be really cool is to build export animations to SD card. We were just talking about that. And that would be really cool, because a lot of times you don't want the whole computer set up with you. Sometimes you do. And, just having the ability to like save those high quality animations to like a offline format would be really cool. So that's something that's like, I'd like to kind of explore that more. Then the really cool thing, this is the thing I'm really not sure if I'm going to keep doing, or maybe I will. It just depends on how viable it is. I'm going to close this down. Is the open fixture markup language project I started. It's very, very early, so there's not a huge amount to show you, but I was talking to you about this the other day. So I'll show you the example of the demo I have prototyped, and this is something I'd have to definitely convert to C++ because it'd be involving SOPs. But these SOPs could potentially be pretty fast, and on another thread, you'd have the ability to really just, pack out your scene with lots of these visualizations. So I guess the problem, I think it's a problem, and like if you guys have any input on this, let me know, because again, this is like something I'm just now exploring, is like it seems like all the lighting fixture profiles deal with a control situation, but if you want to take the lighting fixture profile and also represent the shape of the light in the same file, I didn't see anything that seemed to do that already off the shelf. So my thought was like, it'd be really cool if you could map out your channels in JSON, and then also map out your geometry of that object in JSON, and then link them. So you have your pan channel should rotate this one piece of geometry 540 degrees. And so how do you describe the relationship between those two things? So I built this script chop. It performs horribly. It's like 3 milliseconds, but it's a prototype. I just wanted to see if it could work. So this is just a quick example with a few simple things. We have strobe, right? We'll turn that off. You have dimmer. You have tilt, pan, and this is actually generating all this geometry on the fly inside the SOP, which is why it's kind of heavy for Python. And so this is cool because if you look at this JSON file that describes it, we have this thing called channels. We have min and max, and these are all just red, green, blue, pretty straightforwards. Then you have your dimmer. But what's really cool about this format is that you can map this channel to something else. So to give you a more clear example, let's go find the pan channel. Just kind of collapsing this to make it a little bit more readable. Okay, so pan, right? 0 to 255, but actually what it mapped to is the rotation of a piece of geometry that's probably 0 to 540 or something like that. So for every, you can just keep adding these map items, which essentially say, all right, take the RY rotation of motor pan transform, and basically map 0 to 255 to 0 to 540, and that's going to be an additive function, right? So now you're adding rotation values, and then the reason why this might seem superfluous for pan, but by making it generalized so that it's there for everything, I can also use this for color, right? So if I go up here to red, I'm mapping it the same way, right? 0 to 255 is being mapped from 0 to 1, and this mapping is only for what you see on screen. It's just for visualizing it, right? So now I can map this red channel to literally the texture color, the vertex color of that cylinder. And the idea is that you can kind of build out your fixture using this format. It's a little bit verbose. So like transforms, we have root, motor pan, motor tilt. And so these values are default values, but you can adjust these values with those mappings. And so basically lets you construct your own, it's basically the way to describe this, if you took the OBJ format and like a lighting fixture profile and you jammed it together. It's kind of what I'm trying to do. So yeah, love to hear your thoughts on it. That's kind of a work in progress. It'd be cool to have a way to kind of simulate all of that and move that around to different systems. But right now, my main short-term goal is like, it'd be cool to have better support for visualizing different channels in GeoPix, you know, having pan tilt, also strobe, prisms, and maybe gobos and stuff like that. So yeah, that's all there is to that. Just kind of a work in progress. I think that does it. That's pretty much the end. Yeah. Yeah, thank you for coming. I really appreciate it.